Hello, Pre-Calc. Welcome to our last online lesson of this crazy COVID spring. Today, we are going to do an introduction to parametric equations. And so we've been looking at polar equations. We found out that you don't have to have x and y in terms of rectangular coordinates. You can actually change to an r and a theta, a distance from the origin and an angle of rotation. Well, parametric is looking at a graph in a third way. It is actually looking at, instead of x or y being a function of x, what if we looked at the x and the y separately as a function of a third variable t? And so it's separating the horizontal and the vertical and defining them in terms of a third variable. So here's an example. What if I write x equals 3t and y equals negative 2t? These are two separate formulas for how I'm going to find my x and y coordinates that I'm going to graph. They're not defined in terms of each other. They're defined in terms of t time. So say I am digging a tunnel and I'm digging it at an angle, and x, that's my horizontal distance. So I'm able to dig, if here's my ground, x would be, if I'm starting here, how far to the right am I digging? I can dig 3 feet per day. T is going to be in terms of days. But I can also dig 2 feet down per day. So where's my tunnel going to be after 3, 4, 5 days? Well, I can actually figure that out. The table of values that we create is going to have 3 columns now. This really is just a matter of sort of plugging in values for t. If t is the number of days, where am I on day 0, 1, 2, 3, 4, 5? I'm just going to pick values from 0 to 5. So my x value, I'm going to figure out what my x coordinate is by plugging t values into the equation x equals 3t, because I'm going to the right 3 feet per day. So 3 times 0 is 3, times 1 is, 3 times 0 is 0, just in case you were wondering. And 3 times 1 is 3, times 2 is 6. On the third day, it's 9, 12, and 15. So on the 5th day, I've managed to go 15 feet horizontally. But I've also been going down 2 feet. So I'm really digging at a diagonal here. And first day I start at surface level, and I'm going down 2 feet each day. So notice I'm just plugging in values of t. So negative 2 times 2 is negative 4. Negative 2 times 3 is negative 6. Negative 2 times 4 is negative 8. And negative 2 times 5 is negative 10. So now the points that I will actually graph will be my x and y coordinates. 0, 0, 3, negative 2, 6, negative 4, 9, negative 6, 12, negative 8, and 15, negative 10. And I could graph those on a graph, and this would be the parametric form. I need both an x formula and a y formula in terms of t. That's pretty much parametric form. Now, you actually are familiar with a parametric form equation. It happens to be x equals cosine of theta and y equals sine of theta. And if you go, here's your third variable, theta. If theta goes from 0 to 2 pi and you graph those, you would actually get the unit circle, because any point on there is the ordered pair cosine of theta, sine of theta. And it is theta, that third variable that's increasing, and then you can find the x and y coordinate. So I'm going to take a look at the notes. If you print them off, you can join with me. That's not the one I want. Sorry. Let's start with the graphs. We're going to skip around a little bit, but let's start with number 2 here. Notice that here's the formula for x, t squared minus 7. And here's the formula for y, t divided by 2 plus 5. And I'm given a domain for t. So I'm going to create a table where I'm going to find t, x and y, and t is going to go from -4 to 4. All right. So I like to do these separately and then pull them together to get my ordered pairs. So if I'm plugging in -4, I go square it, 16 minus 7's 9. Square this, 9 minus 7's 2. 4 minus 7's -3. I'm squaring it, so 1 minus 7's -6. 0 squared minus 7's -7. 1 squared minus 7's -6. Now notice what's happening. I decreased. That would be the minimum value. And because it's squared, that's the vertex if I were looking at x as a function of t. And so I know that 2 will be -7. Nope, not -7, sorry, -3. I'm going back up. That's symmetry. And then 3 would be 2, and I could check that. 3 squared's 9, minus 7 is 2, and 16 minus 7 again is 9. And you see that symmetry because the nature of that function for x. Now to find the y coordinates, I'm going to be plugging in each of these values for t into this formula and solving for y. -4 divided by 2 is -2, plus 5 is 3. Let's see, -3 halves, that's -1.5, plus 5 is 3.5. Now notice this went up by 1/2. Well, that makes sense because look at the function for y. It is half of t plus 5. That's a linear form, and the slope is 1/2. So I'm just adding 1/2 each time. So I'm not going to think too hard about this. I'm just going to add 1/2 each time because t is going up by 1. So notice here, when you plug in 0, you get 5 because that would have been the y-intercept. So 5.5, 6, 6.5, 7. So you don't want to do more work than you have to. Now, here's the thing with parametric equations, especially over a given domain. This is the point where we're starting, and they have a direction. Direction is important in parametric equations. So the ordered pair 9, 3, I'm going to graph that, 9, 3, that's where we start. Then we go to 2, 3.5, -3, 4, -6, 4.5, -7, 5, -6, 5.5. Notice this is not a function, is it? Like, would not pass the vertical line test. -3, 6, 2, 6.5, and 9, 7. And so this is actually a sideways parabola. It started here. We started at this point. And so I'm going to connect them in that direction. And I'm going to stop at the end point, but I'm going to put some arrows to show the direction that that parametric equation is graphing. Okay? As t increases, this is the direction we head. So it's a matter of creating a table of values. I'm going to skip number 3, mostly because I just, at this point, don't want to get my calculator out to find square roots. And I think you can handle that if you end up with one of those on your homework. Let's try number 4. I'm going from -2 to 4. So here's t, x, and y. -2, -1, 0, 1, 2, 3, 4. And I want to think about the nature here. X is being squared. So I'm going to square all of those. That will give me my x coordinates. And then y here, that's a linear equation with a y-intercept of -2. I'm going to jump to 0 and put in a -2. And then its slope is 3, so it's going to be increasing by 3. I'm going to add 3, add 3, add 3, add 3, subtract 3, subtract 3. Now, if you don't like my little way of generating points in there and you just want to plug them into that formula, multiply by 3 and subtract 2, that works as well. I'm going to start with my smallest value of t, 4, -8. So there's the point I'm starting with. And 1, -5, 0, -2, 1, 1, 4, 4. Notice we're creating these really interesting curves. 16, 10 doesn't fit on here. I'm not going to stress out too much about it. They're going this way. And I would go, if I had better graph paper, I put an arrow there because I haven't been able to fit that last point on, but it would stop at that point. And put some arrows on there to show the direction that parametric curve is going. All right, let's try one last one here. Notice in example 2 and 4, we had these non-functions. X is not a function of y because it doesn't pass the vertical line test, because that x value had a squared in it. So what's going to happen here if the y variable is the one that is squaring t? See if anything interesting occurs there. We're going to go from -1 to 7. And again, I kind of want to use some common sense here. This is a linear function. I'm just really taking each of these and dividing by 3. So -1/3, 0, this would be 1/3, 2/3, 3/3 is 1, 4/3, 5/3, 6/3 is 2, 7/3. You can put decimals in there if you like. I think it's a little bit easier to graph with thirds personally. And I'm going to square and subtract 6 times that value as well. If it's helpful, you could write that as t times t minus 6 if you like that multiplication better. That would be 1 plus 6 is 7. That would just be 0. 1 minus 6 is -5. 4 minus 12 is -8. 9 minus 18 is -9. 16 minus 24 is -8. Ooh, I feel like I'm decreasing. That might be my vertex there. I'm going to try 5 to make sure I see some symmetry. 25 minus 30 is -5. And do you see that symmetry emerging? This is going to be 0, and then 7. Got ahead of myself there. So now my x and y columns provide the ordered pairs. I'm going to go -1/3 up 7. So I'm starting there to 0, 0, 1/3 -5, 2/3 -8, 1 -9, 4/3 -8, and notice we see the symmetry emerging, 5/3 -5, 2, 0, and this is looking like a parabola, and 7/3, back up there at 7, so we're going this direction, really skinny parabola with some arrows. We are going down and then back up. That is how we graph parametric curves. Looking for values of t, many times they're given, and doing a little plugging and chugging and gain some ordered pairs. Now, some of you are probably like, yeah, but I could write the equation of that in terms of x and y. And yes, you can. That would be going back from parametric to rectangular or function form, and that's what we're going to do next. Can we write parametric equations in rectangular form? Well, yes, we can. We've got to get rid of the t variable. And the way we do that, two-step process, we're going to take one of the parametric equations, either for x or for y, whichever is easiest, really, and solve it for t. And then we're going to do a little substitution. We'll substitute it into the other equation and remove the t, and we'll end up with an equation in terms of just x and y. So let's take a look at some examples. We're going to look at 3 examples, not all of these. Let's look at number 1. If I look at number 1 and I want to solve for t, if I look at x equals 4t minus 1, and I want to solve this for t, I would add 1 to both sides. And then I would divide both sides by 4. So t equals x over 4 plus 1/4. Or you could leave it as x plus 1 over 4. But that means in this equation, the t can be replaced with x over 4 plus 1/4. And now I've got an equation in terms of x and y. And I'm just going to simplify that. Y equals, that would be negative 1/4 x, that would be the slope, and 6 subtract 1/4 is, well, that would be 24/4 minus 1/4 is 23/4. So here would be our our rectangular form equation, because it is an equation for y in terms of x. Let's try the second one. Maybe here I'm looking to solve one of these for t. Well, I think it's going to be easier to solve the y equation because I don't want to take the square root. I'd have a plus or minus. That's too many things to worry about. I can just say that if I divide both sides by 3, t equals y over 3. Now I can take this value and plug it into my x equation for t. T squared, that y over 3 squared, plus 5. Now, right offhand, you should notice that the x is to the first power and y is squared. Had we not had COVID, lots of things would be different. And one of them would be we would have spent a unit on conic sections. What do these look like when y is squared and x is to the first power? Well, that's a parabola. It just happens to be a parabola that's not a function. It is a sideways parabola. We're used to seeing things in y equals form, so we can actually solve this. It's a 3. For y, I think I will take the square root of both sides at this point. So plus or minus, and I'm going to switch sides over here. So y over 3 is going to equal plus or minus square root of x minus 5. And then I'll multiply both sides by 3. So plus or minus 3 times the square root of x minus 5. And this would be our rectangular form. Okay, one more example. Let's jump down here to number 5, because notice, same process as before, but here we are given the values we want to follow for t. So I only want the ordered pairs, the part of the graph where t is greater than or equal to 2 and less than or equal to 8. So we're going to have to do something with that. We're still going to solve one of these for t first. I think I'm going to solve in the x equation because t is to the first power. So add 3 to both sides. Multiply both sides by 2. And depending on your preference, you could distribute that too. Sometimes it's a little bit easier not to. I'm going to show you why I would choose not to. In this case, it's because t is squared. And it's a little bit easier to square for me with that coefficient sitting in front of the quantity. If I go into y, t squared, t is 2 times the quantity x plus 3 squared minus 7. So if I were to square that, I'm going to square the 2, which is 4. And then I'm going to square x plus 3. That'd be x squared plus 6x plus 9 minus 7. Distribute that 4x squared plus 24x. The 4 times 9 is 36 minus 7 is 29. So there is the equation, okay, in rectangular form. Now, I need to somehow get the x values, the domain for x, based off of the fact that I wanted t to be greater than or equal to 2 and less than or equal to 8. Well, here's a formula for t. In terms of, actually, I don't want that form. I want this form. Back to x. I know that if t is 2, that would be the starting point for t. What's the x coordinate that corresponds to it, or the x value? We'll plug in 2. 1/2 of 2 is 1, minus 3 is negative 2. So negative 2 is going to be that smallest value for x. Then plug in 8. That's the largest value of t. And so 1/2 of 8 is 4. 4 minus 3 is 1. So this will be the domain on which we graph this parabola that will correspond to the same graph of these parametric equations. Okay, so for your assignment, you are going to be generating some graphs for parametric equations by plugging in values of t and finding x and y and graphing those points, and then changing from parametric to rectangular form and doing the same for the piece of the graph, restricting the domain, starting off with your t values and finding the corresponding domain for x. All right, I hope that goes well for you. Let me know if I can help in any way.